Welcome to the Engineerable channel. In this video, we're going to look at the current least expensive self-heating 12.8 volt 100 amp hour lithium iron phosphate battery. Whew, that's a lot to say in one sentence. So this battery covers all the needs I was looking for at a price of only $209 each. That is extremely low, and I was worried about the quality of the batteries because I couldn't find anything about the company. The batteries were fairly newly listed. SUNRICH Energy, couldn't find anything about it other than like a simple website. There were no reviews on YouTube yet, no teardowns, so obviously this just hasn't been on the market long enough for people to start taking it apart and showing what's inside and testing it. So I was taking a big risk by buying it myself, but I'm going to do all that testing for you and let you know whether this is a good battery or not. So this battery covers all the needs that I was looking for use in a Sprinter van conversion, an RV, or a camper. So the main things I was looking for, of course, were that it's lithium iron phosphate. Each battery has a capacity of at least 100 amp hours. It's a 12.8 volt nominal battery, has a BMS, and one of the most important things that I wanted is that the battery is self-heating. There are internal heaters inside this battery that will warm the battery up before it starts charging if the battery is close or below freezing. Now you may or may not know this, but charging a lithium iron phosphate battery when the battery itself is below freezing is going to damage the battery. So if the battery is not in a climate controlled environment, if it's in a RV or camper that may not be being used but the solar panel system is working or the charging system is working, or it's on the outside of an RV or underneath the RV in a unclimate controlled space, you're going to need something to heat these batteries up when it's cold outside. Now you might be thinking, why don't I just set my controller, my charger, or whatever, or the battery BMS to cut off charging when it's below freezing? Well, here's the problem. Not all battery chargers, BMSs, solar chargers have low temperature cutoffs. That is not a common feature, so you can't just rely on that working. In addition, what if it's below freezing for multiple days in a row and you're using power from the batteries, let's say running a fridge or running whatever appliances you need, but then you can't charge from solar or plug-in charger for days at a time until the temperature rises above freezing? Well, you're going to run out of battery power. So you can't do that. You need to heat the battery up in some way. I looked at buying some lithium iron batteries and adding a heater blanket around with a sensor and a controller for the heater and stuff, but that was going to add about $100 to the cost of each battery, and oftentimes the self-heating version of a battery was less than $100 extra than the regular battery that maybe just had a low temperature cutoff but no self-heating. So it wasn't really worth it to DIY it. And then when I saw these SUNRICH batteries that were only $209, and they have supposedly 2 heater pads inside that are heating the packs from both directions, so something like 100 watts of heat, that sounded like a great solution to this problem. So again, I was very skeptical about buying a non-name brand battery until I received this package, and I saw that on the package it had Rich Solar tape. Everything on the package says Rich Solar. In fact, there's a label right here that has information from Rich Solar and a model number that's SE-B100. Rich Solar, if you don't know, is a pretty strong player in the solar system, battery off-grid stuff. So they're a quality brand, and most of their batteries actually cost about $500-ish for the same battery. So it looks like what they're trying to do is introduce a lower cost model, but they don't want to cheapen the Rich Solar brand with the lower cost model. The lower cost model may be just as good or the same quality as their other models. They just want to enter the market down low and make money off of the competitors who are undercharging for the price of their batteries. So I felt much better about my purchase after seeing that Rich Solar is the manufacturer or reseller of these batteries, and that knowing that they provide good quality products, this should also be a good quality product. It's time to see what's in the box. Now we see the SUNRICH branding once we open up this outer box. So get these out of here easily. All right, there we go. This is the SUNRICH Energy Packaging was pretty decent. They got foam covering all sides of the battery. The battery came with 3 different sizes of terminal screws. These are all 8mm bolts. I'm going to measure the length of the washers on these. So one of them is 15.5, the other one is 11.25 millimeters, and the shortest is 7.5 millimeters. One thing I wanted to check is how accurate were the dimensions that they claimed. And so I'm going to go from the widest point of the battery, which is 260 millimeters, or 10.227 inches. The bottom of the battery measures 10.05 inches. They claim that the battery length is 10.2 inches, so it's just a tiny bit over that. So the battery width measures 6.59 inches. They claim 6.6, so that's pretty accurate. In millimeters, that's 167.32 millimeters. And the battery height to the top of the plastic is 210 millimeters, or 8.276 inches. And they claim 8.3 inches, so that's pretty accurate. That could be to the top of the terminals. So to the top of the terminals is 8.48 inches, and to the top of the plastic around the terminals is 8.377 inches. The center to center distance between the posts is 8.328 inches, or 211.5 millimeters. The distance to the post is offset from the edge of the battery is 23 millimeters in the width direction, and in the length direction, it's also about 22.5 to 23 millimeters. So I would say that the dimensions in their specs are pretty accurate, and they say that this is a Group 24 size battery. So on the battery, they quote the specs as nominal voltage 12.8, nominal capacity 100 amp hour, charge voltage 14.4 volts. That's a little bit high, usually would charge to 14.2 maximum. Heating function 100 watts, so that's 2 50-watt heaters supposedly. Max continuous discharge 100 amps, max continuous charging 100 amps. Now, charging at 1C is not typically recommended. Usually you want to charge a lithium iron phosphate battery at 0.5C maximum. So you shouldn't charge at 1C, which is 100 amps. You should charge at 50 amps maximum. Since I bought this battery myself and I want to use it, but I also want to take it apart to see what's inside and see if the quality is good, I did not want to break this battery like everyone else who takes the batteries apart or saw the cover off and destroy the battery housing while doing it. So I was actually able to use heat and break down the adhesive that holds the battery on, and it looks to be like a RTV-like rubber adhesive that holds the outside on. So it came apart really well with heat. It wasn't going to come apart without it. And so I can glue it all back together when I put it back together, as long as I continue to take it apart carefully. As soon as you open it, you're greeted with this really nice looking high quality wiring here, bolted on. I don't see any soldering. It looks like it's all crimped into the connectors. And then there's 2 sets of terminals here, also bolted on. The positive is going straight from the cells to the terminal, and the negative is what's being switched on the BMS. This is not a BMS I'm familiar with, nor was I able to find this anywhere online. I was able to translate the Chinese characters and find out the company that makes this BMS. They're also a battery manufacturer, so they make the whole battery, presumably, and they make their own BMS. This looks like a pretty decent quality BMS, just basic. It has no Bluetooth or anything like that, and it's all mounted to this 2mm or so fiberglass plate that's on top of here, which is a nice barrier to protect the BMS from the batteries. I haven't seen that in other batteries that I've seen taken apart. The fiberglass is all glued in, and when I first took it apart, because it was warm, I thought this glue was also like RTV or something rubbery silicone that would be easy to remove later. But once it cooled off, I found out that this is epoxy, and it's hard now. It's not coming out. So I'm going to have to heat that up again in order to be able to remove this fiberglass and check out the cells underneath there. But so far, I'm really happy with what I see in here. So let's heat up this epoxy and take this out and see what the cells are. All right, so check this out. After a lot of careful heating, I was able to remove this fiberglass cover and get a peek at the cells down below, and it looks good. Looks good. I think I can actually drop this whole thing out just by flipping the battery over. It doesn't seem to be glued into the bottom. Everything's coming out. There we go. They put a lot of glue in the bottom, but it didn't really touch the bottom of the battery. I think these zip ties here kept the battery surface off of the bottom, so this glue, all this glue in here they put in, didn't contact the bottom of the battery. So, well, it makes it easier to take apart. Okay, so check this out. Here we have everything. There are some screws on the underside of this piece of fiberglass that hold the BMS to the fiberglass, but fortunately, there's another thick piece of fiberglass on top of the battery, so that prevents the screws from digging into the battery cells themselves. So battery cells are pretty well protected. So the cells look like very good quality cells. The bus bars are welded onto the cells, but looks like a nice large weld for each one, the circular weld. All the wires are screwed onto the bus bars with screws. Even the balance cables are also screwed on with little screw terminals. They have really nice connections. I don't see any soldering. All the wires are just crimped connectors. I would have recommended adding one more foam block like right over here to protect this area from gouging into the case because there's no support on this side over here. The pack is all strapped together with these plastic straps to keep everything tight, and they put fiberglass sheets on all 4 sides of that battery to compress the cells together and prevent them from expanding. They use zip ties to route the wires. It's just a nice touch. So these cables on here are actually a metric size, and the SC10-5 terminals, that's SC10 is 10 millimeters squared. That's the wire gauge in metric, which in AWG size is about a 7 to an 8, but it's closer to a 7 gauge wire, which is not a common wire size, so in between a 6 and an 8 gauge wire. So these wires are pretty heavy duty and they're doubled up. That makes 2 of them, which is 20 millimeters squared, and that's the equivalent of a 4 AWG gauge wire. And a 4 gauge wire over a length of about 1 foot is perfectly suitable for 100 amps of current, continuous. To calculate the resistance of this heater pad, I'm just going to measure the base resistance between the probes. So that's about 0.7 ohms or so. And now I'm going to measure the resistance across the heater. Okay, so the probe-to-probe resistance was 0.7 ohms. So now I'm measuring across the heater, and that's 2.7 ohms. So we can say that the heater is 2 ohms, which if you're using 14.4 volts as the charging voltage, and the heater pad is 2 ohms, then the power is going to be 103.68 watts. So their claim of a 100-watt heater element is correct. I was confused about it being 2 50-watt pads versus a 100-watt single pad because it said dual layer pad, so I thought that meant 2 pads. So having tested this heater pad, it measures 100 watts. But the way that the marketing material is written on the Amazon website says it's equipped with dual layer heating pads totaling 100 watts. That gave me the impression that it's 2 pads because pads was plural and they total 100 watts. They're 50 watts each. Since there are other more expensive batteries that have a 50-watt heater pad on each side, then I assumed that that's what that meant, was 2 pads. But I think what they're saying is it's actually a dual layer single pad that is 100 watts total power, which is what I measured. This pad is very strongly adhered, so probably double sticky 3M adhesive to the bottoms of the cell. Now I'm going to test the voltage of each cell to see if they're all well balanced from the factory. 3.298, 3.298, 3.298, and 3.29899. So the voltages checked out good on all the cells. They're all well balanced from the factory. That's good. There are 2 temperature sensor wires coming from the BMS, and one of them goes over here, and then the other one goes right here. So they're not very far apart from each other, but at least there's 2 different temperature sensing locations. This heater pack power checked out according to the manufacturer's spec. Overall, this physically looks like a very good quality battery, especially considering the extremely low price for a self-heating battery. Okay, so this concludes a teardown of the SUNRICH battery and the physical overview of the internals. Since this battery is so new on the market, I want to go ahead and publish this teardown video because it's going to take me some time to do a charging, discharging testing and cold weather testing to see if the heater works and put that into a video. So make sure you subscribe and stay tuned for my next video where I review those things and do the final electrical review of this battery.